A groundbreaking advancement from the University of Nebraska, Lincoln is pushing robotics closer to human-level adaptability. An engineering team led by Eric Markvicka has developed a soft robotic muscle that can sense, locate, and autonomously heal its own injuries, no human intervention required. Presented at IEEE's ICRA 2025 in Atlanta, this next-gen system replicates the self-repair capabilities of human and plant skin, an elusive milestone in biomimetic robotics. The innovation earned finalist recognition in 3 major award categories, including Best Paper. Magnifying glass tilted left. How it works. The artificial muscle features a 3-layer design. Brain bottom layer, smart skin, a sensing surface made from liquid metal droplets embedded in silicone, capable of detecting punctures and high-pressure impacts. Wrench middle layer, a self-healing thermoplastic elastomer that melts and seals itself when triggered by localized heating. Dashing away top layer, actuation drives motion when activated with water pressure. When damage occurs, electrical signals reroute to the affected area, converting into heat through joule heating. This heat melts the central layer, sealing the damage. Even more impressive? The system can reset itself using a method called electromigration, wiping the electrical memory of damage so it's ready for the next hit. Seedling. Why it matters. This autonomous repair method could redefine robotics in agriculture, healthcare, wearables, and consumer electronics, drastically reducing electronic waste and extending product lifespans. Instead of preventing electromigration like we usually do in circuits, we used it to our advantage, to reset the system for another cycle of healing, said Markvicka. This bio-inspired tech not only mimics nature, it improves upon it, offering a glimpse into a future where machines can recover like living beings.